This last video, the Georgia Milestones review, will cover units 5 and 6, which is statistics and probability. We'll cover numbers 4, 15, 17, 23, 26, 31, 36, 40, and 43. And then that will have us completing all of the Georgia Studies review, Georgia Milestones review. So let's start with number 4. It says, which of the following describes the most representative sample for a survey about how students are going to vote for the candidates for class president at Pablo School? Okay, so we're looking at students voting for class president at a school. So we're going to read through each of these and see if we get a good sample from that. A says the residents of every third house in the school district. Okay, well, that would tell us more than just students. That would give us adults as well. So that A will not work. B, every third person that enters Pablo's science class. Well, that's a biased sample because we're leaving out the people that's not in science class. C, every third person at the school football game. That one's also biased because that's leaving out the people that do not come to the school football game. And D, every third person on the alphabetical list of all the students at Pablo's school. Okay, so this is a good random sample because we're doing every third person and all of the students are given an equal chance of being chosen. So D would be our correct answer there. Our next one is number 15. Number 15 says Aiden rolls a number cube with sides labeled 1 through 6 and flips a coin. What is the probability that he will roll a number 5 or higher and the coin will land on heads? Okay, so we got two different things going on here. We're rolling a number cube, and his coin will land on heads. Okay, so when you roll a number cube, you have the possibility that he's going to roll a number 1 through 6. And when you flip a coin, you got the possibility that it's going to land on heads or tails. So first of all, we need to look at the probability of him rolling a number 5 or higher. Okay, well, if you think about a number cube that has 6 sides, numbers 1 through 6, the only options he has of rolling a number 5 or higher are 5 and 6. Okay, so that's 2 out of 6 chances. Okay, if we list out all the possibilities, 1, 2, 3, 4, 5, and 6 for rolling a number cube. So 5 and 6 are his only options there. So 2 out of 6 options. Now a coin has 2 options only, heads or tails. Okay, so if he wants it to land on heads, that is 1 out of 2. Okay, now remember in class we talked about using the words or and to see if we need to multiply or add these two probabilities together. So he wants to roll a number 5 or higher and the coin will land on heads. So we're doing two things here separated with the word and, so that means we're going to multiply. So when we multiply straight across. 2 times 1 is 2. 6 times 2 is 12. We got 2/12, and we always simplify our fractions, so we can divide both of those by 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. So his probability of rolling a number 5 or higher and the coin landing on heads is 1/6. Okay, let's look at number 17. It says the Greenville Park Rangers want to know the number of visitors who arrive by bus and the number who arrive by car. Park officials record the method of transportation for a random selection of park visitors over 2 weeks. Okay, so here's my little table here, the weeks, people who ride the bus, people who ride in a car. If 500 people visit the park in week 3, which is the best estimate of the number of people who will arrive by car. So this would be a good problem to set up a proportion with. Okay, we're looking at the people who are arriving by car. So we want to know how many take the car out of the total amount of people. Okay, and we can use any one of these numbers. Okay, so if we take that there were 43 people in a car out of a total of, we're going to add 174 plus 43 people to get a total of 217 people, okay, out of 217 people. So we want to see in week 3 how many people ride in the car, which we don't know, out of a total of 500 people. So we could cross multiply to solve this problem. 2 times 7, 217 times x is 217x, and 43 times 500 gives me 21,500. Okay, and then I'm going to divide both sides by 217. So I get x is equal to around 99 people. Okay, now I can look here and see that 90 is my closest choice here to 99. Okay, if I were to do the top one, I could do it as well and add those together. That would give me 38 people out of 223 total if I add these together, equals x over 500. Again, you would cross multiply and you get 223x equals 19,000. And then you would divide both sides by 223. So either one of these weeks you could check. Now this week is going to give you 85 people. Okay, so if we look at these two, 99 and 85, okay, if we find the average of these two, so 99 plus 85 gives me 184, okay, and then I would take 184 and divide it by 2. Okay, 2 goes into 18 9 times, and then 2 goes into 4 2 times. So on average, there's 92 people a week. Okay, so in week 3, if there's 92 people a week, then 90 would be my closest number here. Okay, so we need to find about how many people each week, and then average those together. Okay, so we come up with 92 people, which is approximately 90 people. Okay, so our next one is number 23. The table shows heights in centimeters of members who of the top 2 basketball teams at the tournament. Okay, we got the basketball team, the blue team, and the green team, and their heights. So it wants to know which statement is correct. So the median, is what something that they're asking for. The tallest people is something else that they're asking for. The variability of heights. Okay, so if we're looking for the median, that means we're going to have to put those numbers in order from least to greatest. The first thing we need to do is put them in order from least to greatest. So we'll start with the blue team. So the blue team and the green team is the 2 teams that we have. Okay, and we're going to put them in order from least to greatest. Okay, so looks like 162 is my smallest for the blue. So I'm done with that one. 165 would be next. 168. Then 172. 174. Okay, now notice I have two 177s. 2 tenths is less than 8 tenths. So I'm going to put 2 tenths first and then 8 tenths. Okay, so I'm done with those. So for the green team, my smallest is 176 and 8 tenths. Then 179 and 3 tenths. Then 180 and 3 tenths. Then 182 and 9 tenths. And 183 and 2 tenths. 185 and 4 tenths. And 186 and 6 tenths. Okay. So it says the median height for the blue team is 5 and 4 tenths centimeters less than the median height for the green team. So I need to find the medians of these two. Okay, so there's 1, 2, 3, 4, 5, 6, 7. There's only going to be one number in the middle. So you can cross them out or underline them front and the back, whichever you like to do here. So this is my median for the blue team. I'm going to do the same thing for the green team. And this is my median here. So I'm going to subtract these two, 182 and 9/10 minus 172 and 2/10. And I'm going to subtract because it's telling me that it's less than, okay, so I'm going to see if it is or not. So it's 9 minus 2 is 7, 2 minus 2 is 0, 8 minus 7 is 1. So I get 10 and 7/10 is the median height, so A is not correct. Okay, so B says the shortest person on the green team is taller than the tallest person on the blue team. Okay, the shortest person on the green team, that would be this guy. Okay, is taller than the tallest person on the blue team. That would be this guy. So is 176 larger than 177? That is no. So B is incorrect. For C, on average, the numbers of the green team are shorter than the members of the blue team. Okay, they're around about the same. So that one would not be it. It could be a maybe. So let's see if D's a better answer. There's a greater variability in the heights of players on the blue team than on the green team. Okay, so variability means there's a variety of height. So we go from 162, 165, 168, 172, 174, 177s. Okay, so we go from 160s, from the low 160s to the high 170s. This goes from 176, 179, 180, 182, 183, 185, and 186. So I can tell all of these numbers are very close together. So the blue team has more variability than the green team. Okay, they're more around the same number here. So D would be the correct answer. There's more variability of heights on the blue team. There's more of a spread here than on the green team. Okay, my range is 10 here. If I do 186 and 6/10 minus 176 and 8/10. If I come and borrow here, and 16 minus 8 is 8, and then 15 minus 6 leaves me with 9. So I get 9 and 8/10 is my range. And for the blue team, I have 177 and 8/10 minus 162 and 6/10. And I would subtract there 765. So I get 15 and 2/10. So my range is greater for the blue team. So I know there's more variability there. So that's why 23 is D. Okay, and our next one is 26. Okay, it says Samir has 6 markers in the bottom of his backpack. 1 is red, 2 are blue, and 3 are green. He calculates the theoretical probability of choosing a blue marker at random. Okay, theoretical probability is what should happen. If everything is equal, everything happens perfectly, is what should happen. Then he tests his probability by choosing a marker without looking, noting the color, and putting the marker back into the backpack. Okay, so when you actually do the experiment, this is experimental probability. Samir gets a blue marker in 8 out of 18 trials. How does Samir's experimental probability compare to the theoretical probability, and what is the reason for any difference between them? Okay, so the theoretical probability of choosing a blue marker at random. Okay, so theoretical probability tells me that how many blue markers to total. So there are 2 blues, and total there are 2, 3, 4, 5, 6. Okay, that's my theoretical probability, 2/6 or 1/3. Okay, now Samir gets a blue marker in his experimental probability 8 out of 18 times. Okay, so if I can simplify 8/18 down, since they're both even numbers there, and I would get 4/9. Okay, now to compare these, I need common denominators. Okay, 1/3 and 4/9. Okay, my common denominator between these are 9. So 4/9 would stay the same. Multiply both of these by 3. 3 times 3 is 9. 3 times 1 is 3. 3/9 is less than 4/9. So my theoretical probability is less than my experimental probability. Okay, so theoretical probability was 3/9. Experimental probability was 4/9. Okay, so let's see what happens, what my options are for number 26 here. The theoretical probability is less than the experimental probability. Okay, well, that part is true because we said that theoretical is less than experimental. If Samir did more trials of the experiment, the two values would likely be closer. Okay, the more things you do, the more likely they are to being closer to the actual theoretical probability of what should happen. So that's probably a yes. We're going to come back to that one. Okay. The theoretical probability is greater than the experimental probability. Well, we see that that is false, so B is definitely not in there. The theoretical probability is the same as the experimental probability. These numbers are not the same, so that one's out. And the theoretical probability is less than the experimental probability. Okay, that part is true. Samir did too many trials of the experiment. Okay, you can't do too many of trials. The more you do, the more closer you're going to get to the actual theoretical probability. Okay, experimental probability is what happens when you actually do the experiment. Theoretical probability is just looking at the problem, what should happen. So the more that you do, the more you experiment, the closer you're going to get to the theoretical probability. So the more trials you do, the two values are likely going to be closer together. So A is the correct answer there. Okay, 31 is our next one. The true probability that Rachel will win a raffle is 1/10. Which of the following statements is true? Okay, when we're looking at probability, probability is on a scale between 0 and 1. 0 is impossible. It will never happen. 1 is certain. It will always happen. Halfway between it, we get 1/2. So we have chances that are equally likely. Okay, it could happen or it could not happen. Okay, the closer to 1 we get, the more likely we get. So we could say that this is very likely, okay, to happen here. This would be about 3/4 of the time. And the closer to 0 we get, in between 0 and 1/2, okay, then we would say this is not very likely, or this is the least likely that would happen. That would be about 1/4 of the time. Okay, so we can do these as fractions, and we can also do these as percents. 0%, 25%, 50%, 3/4 is 75%, and then 1 whole would be 100%. Okay, so we can represent it as a fraction. We can do it as percents. We can even do it as a decimal, 25 hundredths, 5/10, or 50 hundredths, and 75 hundredths. So if we look, the true probability that Rachel will win a raffle is 1/10. Okay, so I want to take 1/10 and I want to change it to a percent. So when I take a decimal and change it to a percent, okay, I'm going to take my decimal and move it 2 places to the right. 1, 2. Okay, so I got to fill in that space, so that gives me 10. I add a 0 there, so I get 10%. Okay, so that means the probability of her winning a raffle is right about here on my number line. Okay, so my options, Rachel will definitely not win the raffle. Well, it's not impossible, so she could, so that one's not an option. Rachel is very likely to win the raffle. Okay, well, very likely is over here, so that's not going to happen because she's over here by 0. Rachel is not very likely to win the raffle. Here's not very likely. She's a little less than that, so that's a possibility. And D, Rachel will definitely win the raffle. Well, that would be a certain event, and she definitely doesn't have a certain percentage. That would be 100%. She only has a 10% chance of winning. So my correct answer there is C, that she will not likely win the raffle. She only has a 10% chance of winning. It's not a very good chance at all. Okay, 36 is our next one. Raul has a container of marbles. He draws a marble from the container 200 times, returning the marble to the container each time. The table shows the results. Okay, so he's got red marbles and blue marbles, and he drew 132 red marbles and 68 blue marbles. So just from this table, I can tell that there's probably a lot more reds than there are blues because he got red a lot more times than he got blues. Okay, so if Raul were to draw a marble 300 more times, how many times would he draw a blue marble? So a good way to approach this problem would be to set up a proportion here. Okay, so we're looking at drawing a marble 300 more times, and he wants a blue marble. Okay, so we're doing blue marbles to the total amount of times that he drew. So the first time he did the experiment, he drew 68 blues out of the 200 times that he did the experiment. Okay, I want to see how many blues he will get, which I don't know, if he does the experiment 300 times. Okay, so I'm going to cross multiply to solve this. So I've got 200 times x, that gives me 200x, and 68 times 300, which is 20,400. Then I'm going to divide both sides by 200. So I get x equals 102. Okay, so if he draws 300 more times, he could get a blue marble 102 times. Now, would it be exactly 102 times? Okay, that's a possibility. Exactly 198 times? No, because we got 102 there. That's too much. Or approximately 100 times. Well, 100 is very close to what we've got, so that could be a choice. Or approximately 200 times. That's too much, so we know that one won't work. So now we have a little dilemma here. Would it be exactly 102 times or approximately 100 times? All right. If you are drawing a marble out of a bag, anything could happen. You could get blue or you could get red in this case, okay? Just because you draw 300 times doesn't mean you're going to get exactly 102 of them going to be blue, okay? He drew 200 times the first time and got 68 blues. If he were to do that same experiment again, more than likely he wouldn't come up with the same 68 blue marbles, okay? He would come up with a different number. So an experimental probability here is going to be approximate, okay? We're not sure if he does it 300 more times exactly how many he will get, but he will get approximately around 100. So he'll get, so C here would be my correct answer, okay? So be careful with probability when you do the experiment. Things can happen. Either you could get a red or a blue, so you've got different possibilities there. So it's going to be approximate. Approximately 100 times as he would draw a blue marble. Could be a little more, could be a little less. Okay, our next one is number 40. Okay, number 40 says Alona works in a market research for a sports drink company. They are testing 3 new flavors, cherry, lime, and mango. She asks a group of randomly selected individuals to choose their favorite new flavor and hear their responses. Okay, so we got different flavors, cherry, lime, and mango. And we can see that from this table, lime was the most popular, it had the most votes, and mango was the least popular because it has the smallest number here. Okay, so we have some different choices here to see. If 200 people were surveyed, approximately 100 would choose lime as their favorite. All right. If 200 people were surveyed, approximately 90 would choose cherry as their favorite. If 400 more people were surveyed, approximately 170 would choose mango as their favorite. And if 400 more people were surveyed, approximately 260 would choose lime as their favorite. So the first thing we need to find out on this problem is how many people total were chosen to pick their flavors. So to do that, we would add up the totals here, 156 plus 257 plus 87. So total, there are 500 people. Okay, 500 people selected their flavors here. So I want to see what percentage was chosen. So I would do 156 divided by 500 and then change that decimal into a percent. Okay, 156 divided by 500 gets me 31.2. What gives me 312 thousandths. Now if I change that to a decimal, I'm going to move my decimal place 2 times to the right. So about 31% light cherry. If I look at the lime, 257. So if I look at the lime, 257 out of 500, divide those, and that gives me 514 thousandths, which is about 51%. And then for mango, 87 over 500 is 174 thousandths, which would be, move my decimal over twice, would be about 17%. Okay, so A says if 200 more people were surveyed, approximately 100 would choose lime as their favorite. So 100 out of 200 people would choose lime. So percentage wise, we would take 100 divided by 200 and get 5/10. Change that to a percent. 1, 2, that would give me 50%, which lime here, 51%. So that's a maybe. So we'll put a star by that one. For B, it says if 200 more people were surveyed, approximately 90 would choose cherry as their favorite. So 90 out of 200. Okay, so 90 divided by 200 gives me 45 hundredths. So change that to a percent, that would be 45%. Okay, here cherry was 31, here cherry is 45. So that's a pretty good jump, almost 15%. So that's probably not going to be it. C, if 400 more people were surveyed, approximately 170 would choose mango as their favorite. So 170 out of 400. So 170 divided by 400 gives me 425 thousandths, which is, if I round up, 43%. Okay, way away from 17%. So that one's definitely not going to happen. And if 400 more people were surveyed, 260 out of those 400 would choose lime. Okay, so 260 divided by 400 is 65 hundredths, which would be 65%. Okay, as their that choose lime. Now lime was around 50%, so would it be 50% or 65% choosing lime? I would go with A, 50%, since in my survey up here it was 51%. 50 is a lot closer. So the trend is probably still going to stay very close to the same. And our last one to finish up not only this unit, but the whole entire packet is number 43. It says Fiona rolls a pair of 6-sided cubes, each numbered from 1 to 6 at the same time. What are the possible outcomes of rolling a pair of cubes? Write your answer in an organized list, a table, or a tree diagram. Okay, doesn't matter which one you choose, list, table, tree diagram. It says show your work and write your answer in the space provided. The easy way to do a cube, okay, is just to write it out in a list. Okay, so the first one she's going to roll, she'll get a 1. The second one, she could get another 1. Okay, and then let's do this with an and symbol, 1 and 1. Then she could roll a 1 and a 2 on the next one, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Okay, so on the next time she rolls it, maybe on the first one she gets a 2. Then she'll get a 2 and a 1 on the second cube, a 2 on the first one and a 2 on the second one, and then a 2 and a 3 and a 2 and a 4. And you can see the pattern starting to develop here, okay? And then the next time she does it, maybe she rolls a 3 the first time and then a 1 on the second number cube. So you can see my pattern. Each time my first number changes, and then we're going to see that my second number here, my second roll, will go up by 1. So she can get a 4 and a 4. So she's going to roll some doubles in here. She's going to roll some that just only have one option. And from this table, or from this list here that I'm creating, we can find a lot of different probabilities. So especially if you have more than one question about rolling 2 number cubes, then if you have all your probabilities listed, then they're all here for you to look at. Okay, so those are all my probabilities. Now you can write that as a list. You could have done a table. 1, you could have done 1, and then what she would get, 2s, 3s, 4s, 5s, 6, and so on. Okay, you could have done a tree diagram. If she rolls a 1, then she'll get a 1, a 2, a 3, a 4, a 5, or a 6. Okay, and then she can go do a 2 and a 1 and a 2 and 3, a 4, a 5, or a 6, and then keep going all the way to 6. Okay, so you could have 6 trees with 6 different possibilities there. And so that's all we had to have there. We just had to have the sample space listed there. Okay, now part B says, what's the probability that Fiona will roll double 6s? Okay, well, if I look up here in my table that I created, I look for double 6s. 6 and 6 is what she's looking for. Well, here it is right here. It only happens one time. Okay, so my probability that it's going to happen would be one time, and then we need to see how many times, how many different options we have. So if we count these, 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6. So 6 times 6 gives me 36. There's 36 total possibilities here, and the possibility of her rolling double 6s is 1 out of 36 total possibilities. Okay, that's her probability of getting double 6s. And to write that, we would do capital P, and remember our parentheses, double 6s equals 1 out of 36. And now we are officially done.